Hello, xin chào mọi người đã quay trở lại với kênh Vật lý Chill. Đây sẽ là tập 6 của series phỏng vấn các cuộc thí sinh tham dự IFO, hay còn được gọi là Olympic Vật lý Quốc tế. Trong tập lần này, chúng ta sẽ gặp một khách mời vô cùng đặc biệt khi anh hiện đang là huấn luyện viên của đội tuyển Olympic Vật lý Mỹ, anh Kaishi. Nói về đội ngũ ban huấn luyện của tuyển Mỹ, họ bao gồm một trưởng đoàn hay giám đốc học vấn và 5 huấn luyện viên. Vật lý Chill đã thực hiện các buổi phỏng vấn với vị trưởng đoàn và 3 vị huấn luyện viên, cho nên các bạn hãy luôn đón chờ nhé. Ok, quay trở lại với huấn luyện viên Kaishi. Anh sinh năm 1999, vừa tốt nghiệp Đại học Harvey Mudd, một trong những trường kỹ sư hàng đầu nước Mỹ, với bằng cử nhân, toán, khoa học máy tính. Kaishi giành được huy chương vàng IFO vào năm 2017 và bắt đầu làm huấn luyện viên cho tuyển Mỹ từ năm 2019 cho đến nay. Công việc chính của anh chính là viết đề cho các kỳ thi như F=MA và USA4 hay học sinh giỏi lý quốc gia. Anh chịu trách nhiệm trong việc huấn luyện các học sinh về các chủ đề như cơ học cô điển, điện từ học, thuyết tương đối và thí nghiệm. Wow, nghe là đã thấy hoành tráng rồi nha. Bây giờ chúng ta hãy cùng nhau vào buổi phỏng vấn để biết nhiều hơn về Kaishi nhé.
Hello.
Hey.
Thank you so much for joining us today. And for the quick introduction, yes, my name is Dui. We are honored to have you in our meeting so you can share us like your IFO experience as well as your college life.
Yeah, my name is Julie, and I'm helping to coordinate like these videos and also participating in the interviews and asking questions as well. I'm really excited to have you here today and to learn about your experience.
So for Kai, like about physics, so did you always like have passion for it, or does it come from like some experience when you do something, or you just being curious on your own?
Yeah. So my story of physics is maybe I didn't start with physics. So my mom had this impression coming out of middle school that I liked physics a lot. So what happened was when I moved to a different place for high school, my mom kind of helped ask around with her friends and basically found me a physics lesson to take. She was like, "You like physics, right?" I'm like, "Yeah, I like physics." And so she signed me up for these weekend lessons, and that's sort of how I started doing physics. And sort of the more I did physics through those lessons, the more I started to like it. Yeah, but unfortunately, I didn't, go seeking out physics entirely on my own.
I see. So it kind of started more as like a misunderstanding because like you liked your teacher rather than like the actual class itself.
Yeah.
Okay. But like ever since you like started attending the physics classes, did you ever like join any clubs in high school pertaining to physics or like other interests that you had?
Yeah, so my high school didn't really have any physics clubs. We had probably the closest thing that we had to that sort of thing were like clubs in related subjects like engineering and programming. And programming less so, right? Programming isn't really physics, but sometimes it touches it. And we didn't really have any clubs that were focused around any of those topics either. But one thing that I did do a lot in high school was I had this physics teacher whom I really looked up to back then when I was starting on the physics lessons, and I had problems because this was an extracurricular physics lesson, right? So when I had problems with the homework and I was like, I have no idea how to do these problems, I went to the physics teacher at my high school and I was like, "Hey, I happen to have this homework from outside. Can I ask you some questions about it?" He's like, "Yeah, sure." And then I started hanging out in his classroom and just sort of spending my time after school, just chatting, whatever, with him. He had these cool like physics toys in the back of his classroom. Things like the balls, Newton's cradle, that like go back and forth, and so on. And another thing that he had was like a 3D printer. And so a lot of what I did there was after school, I would go to his classroom and do a mixture of things that were like sort of physics related and sort of engineering related.
Oh wow, that's kind of like remind of my experience too. Like during high school, like
Me
yeah, I'm
too.
just like you. Like I self-study physics just like that. I'm being curious, and only that one teacher in your life, like know your interest in the subject. So just like how your teacher do the same thing with you. So I'm very glad that you have we share the same experience with that. That's very
Yeah, it's
interesting.
pretty amazing.
Yes. So when was the first time that you actually found out about the iPhone, and what made you want to participate in it?
Yeah. So the IFO is sort of an interesting thing. I kind of uh, also found out of it by way of the class that I was signed up for, where basically my teacher had this like class that was just prepare for the F equals MA. And I was like, sure, why not? I'm already doing like first it was an AP class, like it was AP physics. Um, but then he was like, here's a class to help you practice for the F equals MA. And then I'm like, yeah, I liked the other stuff. Why not also take this one? So I started taking the F equals MA. And then it was sort of through doing more about it and being like, wait, what am I studying for anyway? That I learned about IFO and realized that it's like the physics analogy to IMO, right? Like to the math Olympiads. I remember thinking as a kid where it was like, all my parents, like, well, not all my parents, all my relatives would be like, oh yeah, like only the smartest kids do like math Olympiads, right? Those are for geniuses. And then suddenly I was doing physics Olympiad. It's like, huh, this is not actually that hard after all. For some reason, the IMO is like way bigger. Everyone knows about AMC. Not so many people know about the F equals MA. And in my high school, every year they made us take the AMC, but uh, nobody had heard of the F equals MA until like I did through my outside of school class. And then it was sort of through that. And then I told my physics teacher at school about it and basically told him, hey, look, we already do AMC. Why don't we also do this? And then sort of it was kind of after I learned about it and brought it to my school that my school started doing the F equals MA every year as well.
Right, so basically you the first one who brought the FGO to MA to your school, and you only do the first one to start everything too. That's what you mean?
In a way.
Oh wow, that's very impressive. That's amazing. Like yeah.
Yeah, that's
Oh.
pretty cool. Yeah, I wanted to learn more about like a detailed journey of how you studied for the IFO. When did you start like taking calculus, or did you like self-study calculus, or did you like start with like calculus in high school and then studied on your own? Yeah,
There's a lot of parts to that, right, as to how I studied the math parts of physics, like calculus, and also how I studied the physics. Um, so with the math, as in calculus and pre-calculus and whatever, what happened was I had just moved to US for high school, and I was following the standard math curriculum there, Algebra 1 and then Algebra 2 and then pre-calculus and so on. But after the first year of algebra, they made an announcement, they being the teachers, sent out an email and were like, if you think you are good at math, you should take this test and try to place out of the like next math course in the curriculum, which it would have been pre-calculus for me. Um, and I was like, sure, I'm going to take this test for fun because why not? I don't know if people say that normally, but uh, so I went into this classroom like and took this test. And interestingly enough, I was the only one who passed that test. Basically, I was like, oh, great, I skipped out of pre-calculus. Now I'm in calculus. Holy crap, I'm in calculus. I've never heard of calculus before because pre-calculus doesn't do any calculus, right? Pre-calculus is all just more algebra, so solving linear equations, and then trigonometry. So I got really good at like trigonometric identities, just sort of by watching, I don't know, Wikipedia and like Khan Academy videos or something. And then I had never heard of calculus. So then I was like, wait, maybe I should prepare for calculus now that I'm in calculus 1 year before I was expecting to be. And so I like went on Wikipedia and read like, what is a derivative? And it's like, oh, it's a slope of the tangent line or something. And then I watched some Khan Academy videos and I was like, oh, hey, this is not actually that bad. And that's basically how I learned calculus, is by watching these videos and finding out that math is not as hard as they make it out. yeah, and of course some of like the rest of it comes with practice of having like actually using them. I think the in a sense, physics and math are kind of two channels to learning a lot of the same stuff, right? Like um, it's not like I learned physics without learning math, but more that like physics was kind of the way I learned math. And like I mentioned, right, like when I got to multivariable calculus, I actually developed the intuition for multivariable through physics. And physics has that merit where it's like in a math class, especially maybe in a like high school math class, they have a tendency to like tell you the abstract facts, and maybe a good math class will make you prove it. But it takes a really, really good math class to make you think about, um, to make you picture the ideas, because more often they just give you equations and theorems. But physics is kind of interesting because physics simply, like by virtue of being physics, requires you to visualize everything. And so when I was doing math in the context of physics, it really, really helped me build the pictures for the math.
You mentioned like using Khan Academy and Wikipedia to like study up on calculus before you entered the class. Did you use like any other books or resources for your calculus class and your physics class?
Um, Sort of. I've tried to read books, and unfortunately, I have to admit I'm never very good at like actually following through. What always happens is I get a book and then I read the first 5 pages and I stop. And in fact, that I think happened just last week with an algebraic geometry book that I was starting to read. But so as far as books go, fortunately, I didn't really use. I don't think I've ever finished a textbook. Um, but YouTube videos were one thing. Wikipedia were one more thing, and just general Googling. There's this running joke, sort of, that like programmers' only skill is like being able to Google things. And I think uh, maybe the reason I'm good at math and physics is because I transferred my Googling skills from programming to math and physics. A good part of that was also not just like looking for the information I wanted to know on Google, but also once I found it, trying to find like make sense of explanations, right? So like in terms of what it means to Google and learn something, you don't want to just uh, find the equation that you're looking for and then be done with it. But like I like wanted to find the thing that explained it in a way that made the most sense, and sometimes I got pretty angry at websites for having like bad explanations. But that's how I used online resources. And then the one other thing that I guess I did sometimes is because I program, there were some things, especially like when you're learning basic mechanics and kinematic stuff, that you could almost like animate, right? You could write a little Python program that like simulates like an object's like position, velocity over small time increments or something, and then like draw an animation of a thing moving. Doing that sort of playing around with the ideas uh, by way of programming was probably also a way by which I was able to build my intuition for these ideas.
And moving on to the next question, I wanted to ask, did you like conduct any personal physics research or have any projects that you did on the side, just like besides studying for the IFO?
Yeah, so physics research I didn't do um, because physics research is kind of hard to do on your own, I guess, right? Because you need to have like maybe lab equipment and stuff. It depends on where you're doing physics research, right? But if you're doing like actual modern physics research, you got to have like a quantum computer. Nobody has that at their own home. Um, but I did do like most of what I did do was like more on the engineering and like tinkering side of projects. So I mentioned that my physics teacher also did like engineering things, and so sort of through that, uh, a lot of like I played a lot with circuits. There were like times like I did a lot of like digital electronic stuff. Um, I have a thing actually that I may be able to plug in and show you, but actually I don't know if I can. Um, I have a cool thing I have a cool thing. Is it okay if I like take 30 seconds and like
Oh yeah,
try to
that's
find
fine. That's totally fine.
I'm also gonna plug in my phone because it's about to die.
Yes, thank you. That's very extra.
Cool.
We like it.
A couple of months ago, this is terrible. I don't even know if this is gonna work because I wasn't preparing to do this. But now that I thought of it, I figured it could be fun. A couple of months ago, I put together this thing, and I know I'm in college now, but this is the same sort of thing that I did in high school, which is like just this is terrible. This is a terrible circuit. There's no point in me showing you this because it means nothing. But it's like a bunch of wires, capacitors, resistors, LEDs, whatever. And I would just make cool stuff. And what I really want to show you. Right. So this is plugged into a motor over here, and this stuff is 3D printed.
Yes.
And like basically I modeled and 3D printed a bunch of things that like fit onto this. This is the light switch to my room, but there's like some attachments basically, and here's the circuit board I just showed you. And the thing that I made, you can see this light blinking, and it responds to sound, and this thing is a sound sensor. So I'm gonna be really quiet, and I'm gonna show you what it does.
Oh wow.
Wow.
Oh. Oh, that's so cool.
That's cool.
But that's the thing. So the motivation for that, of course, is at night when I am going into bed,
Yes.
I don't want to have to turn off my lights and then try to find my way in the dark to my bed. So I made that thing, but it started out. So the point of me showing you that though was first I did something like this in sophomore year of high school, not using electronics, but using I went on Amazon and I bought a bunch of metal pulleys, and then I just taped them to the floor and the ceiling of my room, and then I taped chopstick to the light switch in my dorm room at the time. I lived on campus, and then I just bought a bunch of string and I tied it to the pulleys on the ground and the ceiling and brought them all the way over to my bed, and then hung these two strings, one to pull in the off direction and one to pull in the on direction, to turn my lights on and off. Everybody thought it was hilarious, and I think so too. And then, but it was projects. I did projects like these, right? And in the process of doing things like this, you inadvertently end up interacting with a lot of things, right? I needed to know how resistors worked, and maybe even how capacitors worked, to make that thing work, right? Of course, you could you could follow a tutorial to make it, right? And that would work. But then first time I tried to power an LED, right? I was like, yes, wow, I can turn on a light. I burned the LED. Why? Because there was too much current going through it and was bad, right? So it's okay, how do I prevent an LED from burning out? And you Google that and they're like, oh, you got to put a resistor. What size resistor should I put there? And they're like, use Ohm's law. And I'm like, huh, what is Ohm's law? Right. And so it's stuff like that I did projects like that, which were all for fun, that happened to give me exposure to things, either in mechanics, the first pulley thing was vaguely related to mechanics, even though it was really just recognizing that the world was full of friction, and every time they tell you to assume things are frictionless, they are wrong. But things like this were kind of my primary way of getting exposed to.
That's so great to hear. Wow, your high school project, you only learn when you burn something, right? Because I myself too, I learn a lot. I'm EE major right now, and I'm pretty sure with you, and when I'm burning stuff, I learn more than my professor doing classroom, because it's so many theoretical stuff, and I don't like it. But I enjoy doing hackathons, doing project with friends, because you burning thing and you laugh together and then you learn together, and that's what you're doing right now. And I hope this is the story of you will actually inspire our students to try it out, do more experiment. Don't just just focus too much on theoretical stuff, solving problem, doing something else too. Yes, thank you so much for that story. Very inspiring.
That was really cool. Yeah, I really enjoyed seeing how like your snap being like turn it on and off. I would totally like buy one. And moving on to like the actual like IFL competition, how did you feel when you're like actually there competing? Was it like intense for you? And how did you feel when you won the gold medal?
I think it was very it was very much a similar experience, like spiritually, um, to the U.S. physics like camp. Like it felt like I was uh, I I felt like I had to like discipline myself almost to like make sure I was going to bed on time because I was not able to do physics the next day if I wasn't having enough sleep. Um, I know you had a question prepared about Jimmy, but I'll share the one thing that I always remember about Jimmy. Um, so Jimmy was that was his second year doing IFO. I had never done IFO before. So I to him he was kind of like the seasoned veteran whom I was taking like advice from. Like he dispensed the wisdom of IFO to us. And I don't know if you like know about this, but our year when we did the IFO, um, there like on the third day, like the day we were supposed to have our like theory exam or something. I don't remember which one it was. They had like a technical difficulty of some sort where like they lost the exam papers or something. Um, and so what happened was they like bussed all of us over to the testing center and got us to sit around in a room. And then they told us, hang on, there's going to be some delays because your papers aren't here yet. So we're like, okay. And then half an hour passes, no word from them. Another half an hour passes. They tell us there's some more delays. And basically this exact thing just happens for the next like 6 hours. We get to lunchtime and they bring us lunch, but they do not bring us our papers. And then we all eat lunch thinking, I wonder when our papers are going to arrive. And it pretty much never does. And they send us home at the end of the day and like take us back in the next day to do the exam. But that one day, I just remember like being like, okay, while we wait for the exam to come, I know other people weren't like this and they did just fine. But for me, I remember feeling like while we wait for the exams to come, I need to make sure that I'm like as well rested as I can possibly be. So I would find like a dark corner inside the center while other people were sitting around trying to pass time and just lie down and try to like take a nap and wait until the papers got here. Because I felt like every bit of concentration I could have counted. So that's the sort of pressure, I guess, that like I had doing it. But it was also really, really thrilling because of that pressure. Like it felt like it was high stakes everywhere. Like it really like imagine being a race, right? It's like pretty much like that. It's like it's you have to be really, really, really on your toes. And that's really stressful, but that's also really exciting. Even though it's drawn out over 5 days. And you know, the last day, that's like the most nerve-wracking thing because like for the entire morning, you're done with all of the work, but all that you can think about is what's going to happen when they make the announcements. And when they announce, congratulations, you got a gold medal. That's like crossing the finish line. And there was a huge kind of sense of relief and sort of like, yes, all of my hard work has finally paid off kind of feeling. Apart from that, my school, who had never heard of IFO before, made a little like, congratulations on being selected to the US physics team award for me. And they gave it to me at the end of year ceremony. And then there was this local ping pong club that I played at every like week. And then when they heard that I like got an IFO gold medal, they wrote a blog post about it.
Wow.
But that's basically it.
That sounds pretty cool. Yeah, it must have felt really nice to like be recognized for that.
Yeah, it was pretty thrilling. It's
Mm-hmm.
yeah.
Yeah, we're gonna be asking you more about like your college and ongoing like plans for the future. And I think this is like really helpful for our viewers to understand from like an American perspective college system, because like our viewers are from Vietnam, and I'm pretty sure they're very interested in studying abroad as an international student. So just like to introduce what your major in school is to our audience, can you tell us what they are?
Yeah. So I major, almost ironically, in math and computer science. It's a joint major, and ironically not physics, but at Harvey Mudd College, which is a liberal arts, but like STEM, science, technology, engineering, math oriented college in 1 hour east of LA. And I picked math and computer science not because I don't like physics, but because if I could major in all three, I would, but I couldn't. And I don't know, it felt like everything that I wanted. Honestly, I can't explain that choice. It just, I had to make a choice, and so I made it.
Okay.
For Harvey Mudd, like our Vietnamese student, I'm pretty sure and in this interview they have no idea about Harvey Mudd, because for them they just know all the school MIT, Stanford, Harvard, like Berkeley, some school like that, or UCLA. But I'm pretty sure they have no idea about Harvey Mudd. So can you share us how is it like to be a student at Harvey Mudd, and what's the culture like? What makes it so unique, and make you have to choose it instead of other school, like if you applied for them?
Yeah. This is my favorite part of talking about Harvey Mudd, which is that, so my least favorite part about being a Harvey Mudd student is, like you said, when I go back and visit all my relatives in China, or whenever I meet, some middle-aged Chinese friend of my parents, and they ask me, what college do you go to? And I say, Harvey Mudd. They go like, what, Harvard? And I have to explain myself, no, Harvey Mudd is this STEM-oriented liberal arts college, 1 hour east of LA, blah, blah, blah. So that's my least favorite part of being a Harvey Mudd student. But as far as what Harvey Mudd is, I would say technical, in terms of how much you get to learn, abilities are on par with the level of, stuff that you would encounter at some of those more famous schools. What sets Harvey Mudd apart from all of those schools is mainly that it is very small. And the reason that makes a difference is when you're in a very small school, and also that Harvey Mudd is only undergraduate, right? Liberal arts college. And together means that Harvey Mudd cares a lot about teaching, and probably more than a school like MIT, right? MIT is very much known for being very good at texting, and it is, but MIT ends up still being a research institution because, at least allegedly, right? MIT professors are famous for being kind of leaders in their field, right? The MIT CS professors are people who have came up with landmark CS results, and really true of anyone who are top of the line in their fields, and they're kind of chosen for their research ability and their accomplishments. At Harvey Mudd, so they'd like to tell us, the professors are chosen primarily for their ability to teach well, or at least their enthusiasm for teaching very well. And this is very, very apparent from at least the way they try to teach at Harvey Mudd. You can see all the effort they put into trying to come up with the most innovative ways and the most kind of engaging ways to teach material to students. And it doesn't always succeed, but you can tell that they're putting in their best effort to teach well. And that's a great thing. And the professors are extremely accessible. And so the fact that Harvey Mudd is really small, and that its professors care a lot about teaching, means that as a student, I could get a lot more access to my professors. I can walk into my professor's office most of the time, and I know almost all of the professors. And we have very kind of a nice casual relationship, and we can I can just walk into the rooms and just ask them about random things. and they're just happy to sit down and chat. And this is kind of a level of interaction, person-to-person interaction with professors that maybe you wouldn't get at a large famous school. And so that is one of the things that makes it special.
Wow, that's so wonderful. We glad to hear so much detail about the Harvey Mudd culture. Oh, I just curious, like, beside Harvey Mudd, like, what other college that you apply to? It's okay if you cannot share to us.
Yeah. I applied to all the UCs, so Berkeley, LA, Davis, Irvine, Santa Cruz, and the rest. Sorry, the rest.
So mainly from the California, like you never look at like outside, like different state.
I also applied to Carnegie Mellon and Harvard and Princeton and Yale and MIT. MIT turned me down. Harvard, Princeton also turned me down, yes. But Harvard offered me a wait list, and Yale accepted me. Yeah, and for a long time, so for the most part, my toughest decision was choosing between the two that gave me full-on offers, which were Yale and Mudd. Actually, what really happened was I got offers. I got an early offer from Yale first, where they were like, "Hey, we really like you. Come to us." And it's like, I wasn't ready for like this. I wasn't expecting anyone to want me, but they wanted me, and this was before my Harvard Mudd decision came in, and I kind of like freaked out because Yale, what a cool place. And so I went and I went to their like admissions program and toured their thing, and chatted with people there, and it was a great place. And back then I got scared, and so I wrote a I was also at the time in Harvey Mudd's early decision, which is binding, as in if they accepted you, you would have to go there. And then I freaked out because I couldn't make a decision between Harvey Mudd and Yale. So I phone called Harvey Mudd, and I was like, "Hey, could you move me from early decision to regular decision so I don't have to commit?" Which is a terrible thing, I think, to say to an admissions officer. But they did it anyway, and they were still gracious enough to accept me. But so I took the extra months to do a lot more kind of touring, a lot more trying to figure out what I wanted and what I liked about each school. Yeah, and then I came to the decision that I ended up coming to, which was that Harvey Mudd cared a lot about teaching, and that mattered to me.
And we believe that was the the most like right decision you have ever made, for sure. Like according to that project you showed, that's definitely the right decision.
Can you tell us more about your application process and what you think helped you stand out aside being a medalist in IFO and USAFO? Do you think it was your other outside projects that you did that you maybe wrote about in your essays?
Yeah, so funny thing is, when I was applying to college, I had not gotten an IFO medal yet because I got an IFO medal the summer before I went to college. So they didn't even know about it, which I like to think is the reason why MIT turned me down, not because I was actually a bad candidate. But I guess one of the things that I think were good in my applications, as far as I can tell, the ones that accepted me, was that you really want to find something that you actually care about and get excited talking about to share in your application, right? You the admissions officers read your thing and they see all the credentials that you have, and they know you're smart, right? They know you went to IFO. And then so if you write a whole essay about how I was learning a lot of physics, and then I'm really, really good at physics. They don't learn anything more about it. What I think really makes you shine is almost having things like this to be excited about, right? Is think about something that is exciting. And for me, there's one more thing that I actually didn't mention that I could mention, which kind of goes back to things I did outside of school related to physics. Was in my boarding school, we had a a pool table, pool, like billiards. So, okay, I'll shorten this. Is I played a lot of pool, and I was really fascinated by how you could like spin the ball, and I like spent a lot of time practicing for that. And in the process of that, of course, like with many of the things that I was excited about, learning about that also made me like learn about mechanics, right? And I like went on Google and I found these articles about like the mechanics of like pool spins, and like found this ancient textbook by this one guy on pool mechanic, like who was some like pool mathematician expert or something, and about like what like how to angle your like cue stick to get it to like roll in a certain direction or something. And so that's one thing I wrote about in my Yale application. The reason like it's good, I thought it was good because it was something that I was genuinely excited about. I would spend like many hours every day after school, because I had the free time back then, to playing with pool and like exploring that sort of stuff. And so then I had stuff to write about, and they could tell from what I was writing that it was something that I loved to do.
I really hope that your passion can like motivate and inspire like other viewers to pursue their own passions as well.
Yes,
Yeah,
exactly.
I
I definitely believe that. So about your future plan after graduation, because we believe that you're gonna graduate this year. So what is your plan? Like, what do you think you're gonna do? Like, are you going to grad school? Are you kind of like do something for the companies? Or you working as a senior coach for the Eiffel team?
Oh yeah, yeah. Those are very good things to think about. So this year I'm actually taking a gap year because you know why? From school, because I want to go back on campus. Like I'd like to finish my last year on campus because there's a lot more things I can do on campus that I can't do from home. So I'm like, I might as well just wait. So I'm on a gap year this year, and so I'm going to delay my graduation by 1 year. After that, the plan is to go into grad school in some intersection of math and computer science. Probably math, but also maybe computer science. I don't know. I haven't really figured it out. I've spent a couple summers doing like internships at companies, especially like CS companies. You make good money doing that. But I think in a way, like that was a very much like a 9 a.m. to 5 p.m. like routine. And the whole day is like you're in the office. And it was kind of fun. But there's a part of me that wants to do like more. Like I like having some independence almost. Like I like being able to choose what I do and being able to, I don't know, just mess around. Like, in a 9 to 5 job, you don't get the time to make things like this. Yeah, so I think I'm planning on going down the grad school route for now. In the summers, I'm trying to find more time to do these, or dedicate more time to these like teaching programs, like being a coach for the U.S. physics team. I also recently joined a cool math program called Mathly as an assistant instructor. And I think more and more of late, I guess I've been thinking about how to teach things well. Maybe part of it is sort of like owing to the fact that I was really, really lucky to have really good teachers as a student. And also because while I was learning, right, finding the best explanations and best, having the best teachers was the thing that made me the most excited. And so being able to like use those skills and try to think about how to teach well is also kind of exciting to me in the same way. I don't know what I'm going to do after grad school. That's a distant future, they say.
Yeah, sounds like you could go down like the professor route, or maybe even like a physics teacher at a high school, or at your old high school even. Yeah.
Yeah.
And then just to wrap everything up, I just want to say thank you for your time. And I have one final question. as you know, to you as a current coach and a former contestant current for the IFO, do you have like any tips or advice for students who are interested in physics and have no clue where to start? And do you have any words of encouragement for them just to help them, you know, motivate themselves through the process?
Yeah. Everybody says physics and math are really hard, and like the people who are good at it are really smart. And that's like true, but it's also not true in the sense that you don't have to be a genius to do those things. Rather, it is doing those things that makes you smart, I think. And so what matters, I think, to me, that I think is really the main reason I know anything is being able to remember and remind myself. Being excited about something is really the main reason I learn anything. And if you are excited about physics or about anything, hang on to that feeling and just pursue it, because the answers are out there somewhere. And as long as you're excited about it, you'll find a way, I guess. Yeah, okay, one other small piece of advice, which is to not be satisfied with what they tell you in school. And what I mean by that is, and I sort of, was saying this, is like, when you learn something, I think a lot of the times, the stuff you find in textbooks and in school don't do the material justice in terms of making it exciting, like really thrilling. Like high school math is thoroughly boring because all of it is, like here's a set of problems and you just follow these steps and you solve them. But it's a lot more interesting than that, because it's really about being able to come up with your own questions and ask them. So I think the thing to to make the thing to make things work is, don't take an answer. Don't accept to just be given facts. Don't be satisfied until you know exactly why. Until you really know something and understand it. And when someone just tells you, a fact, this is true about math in general, anything that is math-ish, is if someone tells you, so-and-so is true, you have to indignantly ask why, and refuse if they just say because it's true. But to say that if you put in the effort and you manage to find the answers, then they will become.
That's a lot of extra information, also new too, unique information. I'm pretty sure we will never hear this until we reach out to you. That's incredible, and I hope that you can carry this for the younger generation. Try to instill those mindset, the incredible mindset to them, teach them, always be excited just like you.
Yeah, I think I really enjoyed listening to your story, and just like we said, I rarely encounter such passion for topics, so it's really nice and refreshing to see that from your perspective. So I really appreciate getting the opportunity to meet you as well. Thank you so much for
It's nice to meet you, Kai. I admire you a lot.
It's been a total pleasure. Thanks for having me.
Wow, quả là một buổi nói chuyện rất là thú vị với huấn luyện viên Kai Shi. Huấn luyện viên Kai không có một thành tích hồi cấp 3 nổi bật như các khách mời lần trước hay là học nhảy lớp ở trường đại học. Anh rất ít đọc sách giáo khoa và có một lộ trình học tập rất là đơn giản, khi các kiến thức toán và vật lý của mình đều có được từ Google, YouTube, Wikipedia hay là Khan Academy. Nói chung, mọi kiến thức mà anh có được đều là do sự mày mò của bản thân, tìm kiếm trên mạng. Nhờ kỹ năng search Google này, nó đã giúp anh học tốt môn toán và khoa học máy tính ở trên đại học, bởi vì dân IT cần Google nhiều lắm đó nha. Ở huấn luyện viên Kai, mình rất là ngưỡng mộ các đức tính sau của anh. Thứ nhất, đó chính là niềm đam mê vật lý cháy bỏng. Mọi câu trả lời của anh trong buổi phỏng vấn đều toát lên sự nhiệt huyết, hứng khởi và niềm vui sâu sắc với bộ môn vật lý. Anh như là một đứa trẻ, luôn tò mò và luôn muốn tìm hiểu câu trả lời tại sao và khát khao học nhiều hơn nữa. Ngoài ra, anh cũng là một người rất thích học đi đôi với hành. Khi tự mình lắp các mạch điện, LED nè, công tắc nè, và thậm chí viết ra các chương trình mô phỏng bằng ngôn ngữ lập trình Python về các hiện tượng vật lý. Chưa hết, anh không phải là người luôn luôn giữ các kiến thức và kinh nghiệm cho bản thân mình. Thực tế, anh rất muốn chia sẻ các kiến thức này đến với mọi người thông qua việc làm huấn luyện viên cho đội tuyển Mỹ. Điều này không những giúp anh củng cố các kiến thức vật lý mà còn truyền lại ngọn lửa đam mê cho các thế hệ trẻ sau này.
Được. Hào Án.
Buổi phỏng vấn này thực chất kéo dài hơn 2 tiếng, nhưng vì sợ khán giả không xem hết cho nên anh đã kêu bọn mình cắt bớt đi một chút. Và đó cũng là những gì mình có trong video lần này. Vật lý Chill sẽ cố gắng ra video đều đặn hơn cho mọi người. Do công việc và cuộc sống khá là áp lực cho nên tần suất ra video không được nhiều như trước, nhưng cả team sẽ luôn luôn cố gắng hết sức. Nếu các bạn có những chia sẻ hay comment gì thì hãy để lại ở phần comment bên dưới nhé. Ở tập tiếp theo, chúng ta sẽ gặp thêm một vị huấn luyện viên khác của đội tuyển Mỹ, cho nên mọi người hãy luôn đón chờ nha. Xin chào và hẹn gặp lại. Bye.